Dear students, today I will take new topic, that is sectioned convolution. The response y of n of any LTI system is computed as the linear convolution sum of system impulse response h of n and the input sequence x of n. That is, y of n equal to x of n convolved with h of n. So I'll write here the response of an LTI system for any arbitrary input is given by linear convolution of the input and the impulse response of the system. If one of the sequences, that means either x of n or h of n, is very much longer than the other, then it is very difficult to compute the linear convolution for the following reasons. First one, the entire sequence should be available before convolution can be carried out. What it means then? Let us say here LTI system considered is real-time system. That means the input will be coming continuously and the output will be produced continuously. But when input is coming continuously, the length of x of n will be very large, and for the purpose of computation of convolution, x of n at any time instant will not be available completely. Therefore, it becomes difficult to compute y of n as convolution of x of n and h of n. Second reason is large amounts of memory is required to store the sequences. So this problem can be overcome by using sectioned convolution. The above problems can be overcome in the sectioned convolutions. There are two methods of sectioned convolutions. They are overlap save method and overlap add method. Now we will see these methods one by one. First we will take overlap save method. Let us say we have two sequences x of n of length n1 and y of n of length n2 such that n1 is greater than n2. Now we will write the procedure to compute the convolution of x of n with y of n in steps. Step 1, divide x of n into sections of size n3 samples. Usually n3 is equal to n2. If x of n is divided into x1 of n, x2 of n, x3 of n and so on, then x1 of n will be of length n2 samples. And these n2 samples will be the first n2 samples of x of n. So we'll write here first n2 samples of x of n. In x2 of n, the first sample will be the last sample of x1 of n. So we'll write here last sample of x1 of n, and here we'll be having next samples of x of n. But here we have to select the next samples of x of n such that the length of x2 of n will remain n2 only. Similarly, we have to write for x3 of n, x4 of n, dash dash dash. Say last sequence is xp of n. In last sequence, the first sample will be last sample of xp minus 1 of n, xp minus 1 of n. and the remaining samples will be next samples of x of n, such that the total length of xp of n becomes equal to capital N2. If there is shortage of samples from x of n to place here, in that case we have to pad with zeros. That means at the end we have to place zeros of required number. Step 2. We have to find circular convolution of x1 of n, y of n, x2 of n, y of n, and so on up to xp of n y of n. In step 2 we have to find the circular convolutions of x1 of n with y of n, x2 of n with y of n, and so on up to xp of n with y of n. And these circular convolutions will call as y1 of n, y2 of n, yp of n. Step 3. Place y2 of n below y1 of n such that last sample of y1 of n and first sample of y2 of n overlap. Now below y2 of n place y3 of n similarly. Repeat it up to yp of n. Step 4. Discard first sample of y1 of n, y2 of n dash 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 up to yp of n. and write the remaining samples in order to get y dash of n. To understand the overlap save method, we will consider one example. Compute linear convolution of x of n with h of n by using overlap save method where x of n is equal to 1, minus 1, 2, minus 2, 3, minus 3, 4, minus 4, and h of n is equal to minus 1 plus 1, 0. Solution. Given x of n is equal to 1 comma minus 1 comma 2 comma minus 2 comma 3 comma minus 3 comma 4 comma minus 4, let its length be equal to n1, and that is equal to 8. H of n equal to minus 1 comma 1 comma 0, and let its length be equal to n2, and that is equal to 3. In step 1, we will divide x of n into sequences of length n2 equal to 3. Dividing x of n into sequences of shorter length, we have x1 of n equal to 1 minus 1, 2. x2 of n equal to, as explained in the procedure, the last sample of x1 of n should be the first sample of x2 of n. So 2 will be written here. and next two samples will be from x of n, that is -2 and 3. Now you have to repeat this and write x3 of n, x4 of n, and so on. When we write x4 of n, we find there are only two samples. So you have to pad with 1 0 here, so that length remains equal to 3 only. Step 2. In step 2, we have to find the circular convolution sums of x1 of n, x2 of n, x3 of n, x4 of n with h of n. And the outcomes we will call as y1 of n, y2 of n, y3 of n, and y4 of n. So y1 of n is equal to x1 of n circularly convolved with h of n. We'll use here matrix method. Y1 of n will be equal to circular convolution of x1 of n with h of n, 1 minus 1 2, 2 1 minus 1 minus 1 2 1, and here we'll write h of n, that is minus 1 1 0. Multiplying and adding we get. You can make use of your calculator because it is 3 by 3 matrix multiplied with 3 by 1 matrix. One into minus 1, 2 into 1 2, 2 minus 1 is 1, minus 1 into minus 1 plus 1, 1 into 1 1, so 1 plus 1 it will become 2, 2 into minus 1 minus 2, 1 into minus 1 minus 1, so minus 2 minus 1 we get minus 3. Similarly, y2 of n equal to two minus 2 3, 3 2 minus 2 minus 2 3 2, 1 with minus sign, 1 0. If you multiply these two matrices, you will get 1 4 and minus 5. Next, y3 of n. Three minus 3 4, 4 3 minus 3 minus 3 4 3, minus 1 1 0, minus 3 plus 4 will get plus 1 plus 3 plus 3, you will get 6, minus 4 minus 3, you will get minus 7. Next we will calculate y4 of n. Four minus 4 0, 0 4 minus 4, minus 4 0 4, minus 1 1 0, 4 into minus 1, minus 4, minus 4 plus 4, minus 4 into minus 1, plus 4, plus 4, plus 4 into 1, 4, it will become 8, 0 0 minus 4. All right, step 3. In step 3, I'll first write 1, 2, minus 3. This is y1 of n. Below minus 3, I will write that the first sample of y2 of n, that is 1, 4, minus 5. So 1, 6, minus 7, then minus 4, 8, and minus 4. Draw a line here. Now step 4. Discard first values of all the convolution sums. And write remaining samples in order 2, minus 3, 4, minus 5, 6, minus 7, 8, minus 4. Now this will give us the required result y of n. The next method of convolving a long sequence with short sequence is overlap and add method. In this method we will be making use of linear convolution. So before we actually get into this method, I would like to explain you a simple method of computing linear convolution sum, defined as y of n equal to x of k into h of n minus k, summation of this product from k equal to minus infinity to plus infinity. Example. Calculate y of n equal to x of n convolved with h of n, where x of n is equal to 1, 2, minus 1, 3, and h of n is equal to 1, 0, 1. Solution. To compute linear convolution of x of n with h of n, write the samples of x of n horizontally and the samples of h of n vertically. Then draw a table like this. Now multiply 1 with 1 and write the product here. 1 with 2, write the product here. 1 with minus 1, write the product here. 1 with 3 and write the product here. And so on. That is 0, 0, 0, 0. 1, 2, minus 1, 3. After this, you draw the cross lines like this. Now add the numbers in each box and then write them. Here is only one element, so it is 1. Here in this trapezium you are having 2 elements, add them. 0 plus 2, 2. And here you are having 3 elements, sum of them is 0. Here you add these elements. 2 and 3 added will become 5. Minus 1 plus 0 will become minus 1. Lastly, you are having only 3, right? 3. So at the end, you will find the numbers added this way. 1 from here, 2 from here, 0 from here, 2 plus 3, 5 from here, 0 minus 1 here, 3 here. Now this is nothing but y of n. So what you have written here? You have written x of n. And here we have written h of n. Now y of n is nothing but linear convolution of x of n with h of n. So it is very simple and fast method of computing linear convolution sum. Now we will take up second method of convolution of a long sequence with a short sequence, and that method is overlap add method. Let us say we have two sequences of length n1 and n2, namely x of n and h of n respectively, such that n1 is greater than n2. Step 1. Divide x of n into sections of size n2 samples. If necessary, pad the last section with appropriate number of zeros. So we'll be getting here x1 of n of length n2, x2 of n of length n2, and so on. Say last sequence is xp of n of length n2. Step 2. Now we have to perform linear convolution of x1 of n with h of n, x2 of n with h of n, and so on up to xn of n with h of n to get y1 of n, y2 of n, and so on up to yp of n. That is y1 of n equal to x1 of n convolved with h of n, y2 of n is equal to x2 of n convolved with h of n and so on up to yp of n equal to xp of n convolved with h of n. Step 3. Place y1 of n, y2 of n and so on up to yp of n. One below the other, such that last element of y1 of n overlaps with first element of y2 of n, comma, last element of y2 of n overlaps with first element of y3 of n and so on. Step 4. To obtain y of n, write the samples of y1 of n y2 of n and so on up to yp of n. After adding the samples, which are one below the other. For understanding purpose, we'll take one example. By using overlap add method, find y of n equal to x of n convolved with h of n, where x of n is equal to 1 comma minus 1, 2 comma minus 2, 3 comma minus 3, 4 comma minus 4. H of n is equal to minus 1 comma 1. Solution. Given x of n equal to 1 comma minus 1, 2 comma minus 2, 3 comma minus 3, 4 comma minus 4, and h of n is equal to minus 1 comma 1. Step 1. Sectionalize x of n into x1 of n, comma x2 of n, so on up to x4 of n, each of length n2 equal to 2, where n2 is length of h of n, and that is 2. So now we will write x1 of n equal to 1 comma minus 1, x2 of n equal to 2 comma minus 2, x3 of n equal to 3 comma minus 3, and x4 of n equal to 4 comma minus 4. In step 2, we will find the convolution sums of x1 of n with h of n, that is y1 of n, x2 of n with h of n, that is y2 of n, and so on. So first we will find y1 of n, that is x1 of n convolved with h of n. We will make use of the tabular method which I have explained in the beginning of this class. For that, we will write the samples of x1 of n horizontally and h of n vertically, and these samples are 1 and minus 1 and minus 1 and plus 1. Multiplying we get minus 1 plus 1, 1 and 1, and minus 1. Adding the obtained products here, y1 of n is equal to Here is only one element, so it is minus 1. Now we are having two elements here. 1 plus 1, 2. And there is only one element, that is minus 1. Similarly, we have to find the remaining convolution sums. y2 of n is circular convolution of x2 of n with h of n, minus 1, 1 here, 2, minus 2 here, minus 1 into 2, minus 2, minus 1 into minus 2, plus 2, 1 into 2, 2, 1 into minus 2, minus 2. Again add this to get y2 of n, that is minus 2, 2 plus 2, 4, and then minus 2. Next we will compute y3 of n. That is x3 of n convolved with h of n. You can show arrow marks here also. x3 of n has 3 and minus 3 as its samples, and h of n has samples minus 1 and 1. Multiplying we get minus 3 plus 3 plus 3 minus 3. Adding these we get y3 of n, that is equal to minus 3, 6, minus 3. Next we will find the convolution sum of. Similarly, computing y4 of n, we have minus 4, 8 and minus 4. In step 3, we have to write the convolution sums one below the other. y1 of n, y2 of n, y3 of n, y4 of n, such that the last element of y1 of n will be above the first element of y2 of n. The last element of y2 of n will be above the first element of y3 of n, and so on. That is, now we have to add the samples here which are one below the other and write for y of n. That is step 4. Below minus 1 I don't have anything, I will write here minus 1. Below 2 nothing is there, I will write 2. Minus 1 minus 2 is minus 3. 4 as it is. Then minus 5, 6, minus 7, 8 and minus 4. Now this is required y of n. That is x of n convolved with h of n, which we called y of n, is equal to minus 1, 2, minus 3, 4, minus 5, 6, minus 7, 8, minus 4. With this, we have completed Unit 1. From next class onwards, I will be starting with Unit 2. Now I will stop the class. Thank you.